Imagine you run 10,000 stores across the US. Every time a customer walks near one, you have a chance to bring them in with the right offer at the right moment. But the decision depends on their history, their habits, your campaigns, and where they are right now. Many technology teams struggle to act in that window because the systems that traditionally had to be built for this are fragmented, fragile, costly, and slow. Today, I'm going to demo a solution to this problem that is contained in a single runtime, solving those challenges. I call this Nearstore Agent, and this is how it works. So taking a look at this diagram, what we have here on the top is the customer's phone, which is essentially sending GPS pings to the server. This server is running in a single process, so the Harper Unified Runtime. In this scenario, what we're doing is a proximity check. So we're doing the geo lookup directly within runtime. If they're not near store, process ends. If they are near store, we take the next step. And what you see here is we're starting to assemble the context. In this scenario, we're going to send offers to somebody, promotional offers, depending on how close they are to the store. Really, if they're within 500 feet of the store, we'll send them an offer in this situation. So we want to have their customer profile, their order history, their campaigns, and any business rules that apply to this promotional activity. So we're assembling that context. And what's different and unique about what we're doing within the Harper runtime is we're actually also storing the data. Sure, Harper has the ability to connect and capture data and request data from other APIs. But we can also have webhooks and other things that allow the data to be pushed to Harper. So it's always available and ready to go. The benefit of that being that you really have extremely low latency and you're reducing like network traffic, so that every time somebody is near a store, you're not having to query all of these parameters. You already have them right there. Once the context is assembled, we send the prompt to the LLM. For this example, I'm using Claude, and then Claude sends back essentially a decision. From there, the decision is to send an offer or not to send an offer. Claude is the one making the choice there. Based on the habits of this person, it's not always great to say for somebody that only comes in the morning, do we want to send them an offer for dinner? Maybe we do, maybe we don't, but that's ultimately up to the business rules to decide. So we decide to send an offer, and that offer then gets pushed out and goes back to the customer's phone. That's what this looks like in practice. This is what we're building, a location-aware agent within the Harper runtime. A super efficient way of doing this. I also want to point out that this is assembling context and we're doing LLMs, but what we end up doing with that information of where they're at can really do a bunch of different things. It could be a promotional thing, but it could also be, are they near our store because they're about to pick up their order? Oh, let's start staging that order. There's so many other practical use cases for implementing geo-aware uh, unified runtime systems, be that agentic or not. It's the simplest way to create a geo-aware service. So let's take a look at what this looks like in practice. I'm going to restart this demo here. And what we're going to see is what I've done here is I preloaded 25 different McDonald's stores around Denver. Chose McDonald's because there was a lot of them and they were nicely situated. It'd be this 25 or 10,000 stores. It really doesn't matter in this situation. With 10,000 stores, probably wouldn't be hosting this on a laptop, would likely be using Harper Fabric, which would allow you to distribute that in a geo-distributed network of servers for essentially decentralized agents in this situation, allowing you to respond to all of those requests and hitting millions of location pings per second is really not a problem at all. And plus doing all of the other process of looking this stuff up. So we're going to test this out. You can see here that I have the customers different that I have loaded here. In reality, we might have millions of customers here that we would be aware of. They're sending with their ping, so we can look up their information really quickly. It's just a key value lookup within the Harper runtime, and that really runs within like 1 millisecond. So extremely fast process. You can see here. So I'm going to start off with this family here. We're 423 right now. So I'm going to click around here and we can see right away it said no McDonald's within 500 feet. So it essentially made a decision to not call the LLM and not do decision. I'm going to zoom in here. I'm going to drop this location ping directly next to this McDonald's here. So you see right away, we've sent it off to the LLM to make the decision. And here we've identified the store we're close to. And here we've had a positive offer for dinner time, family bundle at East Colfax, 2 Big Macs, 2 Happy Meals for $24.99. This knew that the customer, part of a family here and often orders with their kid, so it's customize the offer just for this person. Then over here, let's go to Jordan late night. Let's go to a different location. Let's see what this comes up with. So we're saying that to Claude, okay, this person is pretty much someone that just shows up to McDonald's late at night. So the agent here decided to hold and not send an offer at all. So you can really see that by having these like specific profiles for people, being able to look that up quickly and to send that context to an LLM, we're really creating this location aware agent system that is able to send extremely relevant personalized offers to individuals. And it's able to do this across millions of potential customers by pinging their location depending on where they are. If you want to build something like this yourself, so just cloning the repo as a good starting point. It's really easy to use coding agents today. Take this repo as an example to understand how we're doing the geo lookups. I could definitely do this a lot finer grain, especially if you're only looking at doing that in select areas. Like let's say you want to see like where they're walking in a mall and you want to ping somebody when they're within like 3 stores of your store. This is totally doable with this kind of setup. So clone the repo, take a look at it, alter it yourself, or have AI work with it to really build the system that you need here. Since it's a contained, unified runtime, it's really easy for the coding agent to reason about it. So clone this repo and make a version of this that works for your use case. Excited to see where you take this. If you need any help, make sure to reach out in the Discord channel where you can go to harper.fast/Discord. You'll be routed right to our Discord channel where you can join, ask any questions, and we have plenty of engineers ready to help you out. Thank you for taking the time today to watch this demo. Well, I hope you're excited about this as we are.